we want to convert the point given in cylindrical coordinates to Cartesian coordinates or rectangular coordinates. So because we're given these cylindrical coordinates, we know r equals 3, theta equals 7 pi divided by 6, and z equals negative 4. To find the Cartesian coordinates, we need to find x, y, z, where x equals r cosine theta, y equals r sine theta, and the z coordinates are the same. So we know that x is going to be equal to 3 times cosine 7 pi divided by 6, and we know y is going to be equal to 3 times sine 7 pi divided by 6, and z is going to equal negative 4. So to find these two trig function values, we can use a reference triangle or the unit circle. We'll go ahead and show both. 7 pi divided by 6 radians terminates in the third quadrant here, where we'd have a reference angle of pi divided by 6 radians, or 30 degrees. 7 pi divided by 6 is equal to 210 degrees. So the reference angle is pi divided by 6, or 30 degrees. So we have a 30, 60, 90 reference triangle. So we can label the sides 1, 2, and square root 3. But because we're in the third quadrant where x and y are both negative, both legs would be negative. So for x, we have x equals 3 times cosine 7 pi over 6 is equal to the ratio of the adjacent side to the hypotenuse, which would be negative square root 3 divided by 2. We'll verify these trig function values in just a moment on the unit circle. And for y, we'd have 3 times sine 7 pi over 6, which is equal to the ratio of the opposite side of the hypotenuse, which would be negative 1/2. Let's quickly verify these two trig function values on the unit circle. Notice here at 7 pi divided by 6 radians, x is equal to negative square root 3 divided by 2, and y is equal to negative 1/2. So these coordinates do verify the values of cosine 7 pi over 6 and sine 7 pi over 6. Let's go ahead and find these products. The x-coordinate is going to be negative 3 square root 3 divided by 2. The y-coordinate is going to be negative 3/2, and the z-coordinate is equal to negative 4. From the directions, it does appear our homework would take a decimal approximation for the x-coordinate, but let's go ahead and use the exact value. I hope you found this helpful.